We will solve more problems on vertical motion. Here we have a problem that a ball is propelled straight upwards from the ground with initial velocity 9.6 meter per second. Ignoring air resistance, find an equation for the height of the ball at any time t. Also determine the maximum height and the amount of time the ball spends in the air. So this is a long question. They have asked many things, but always, whenever you have such problems, on projectiles or vertical motion or acceleration, first thing, see what is given. Write the given. That is initial height. They have not mentioned anything about direct meter is not mentioned. Meter per second, is always velocity. So initial velocity is upwards from the ground plus 19.6. Height, nothing is given, so it's 0. Okay, so now what happens? Next thing, see what do you want to solve. See what are they asking you to solve. Now here they are asking you height of the ball at any time t, that is h of t. Okay, it's very simple. Integrate the acceleration, that is 9.8 minus 9.8 meter per second. You will get h dash of t, that is velocity, and integrate this h dash of t, you will get the height. So it's very simple. Okay, that is fine, but that's not it. They want the maximum height and the time in air. So let us start solving it one by one. So find the velocity integrating acceleration. If you do not know this, I would recommend you to pause this video, go back to the previous video, watch it, be thorough, and then come to this. Now, we have done the same thing in the last video, last section, last problem over there. So you have to just find the, you should know this acceleration. You have to just find the integral. So h double dash of t means acceleration. Integrate this, you'll get velocity. H dash of t. That is integral of minus 9.8 dt. That will be minus 9.8 t, because it's a constant, so t will be multiplied, plus c. What is the c? Constant of acceleration. You have to find this. How do you find this? You know the initial velocity is given h dash of 0. Substitute. To find the c value, substitute this h dash of 0 over here. When h dash of 0 happens, this t will become 0. Every way t is 0, right? So this t becomes 0. What is h dash of 0? 19.6. That is the c value. In the last video, I told you whenever it is just linear or quadratic, you don't even need to solve it. You know the c value will be the same thing. Okay. So now h dash of t is minus 9.8 t plus the constant of acceleration is 19.6. Okay, we have found h dash of t, but this is not what we want. We want the position, say over here h of t. So find equation for the height by integrating the velocity. When we integrate the velocity over here, it will be minus 9.8 t square by 2. We had this similar equation in the last problem. The same type of similar problem, similar answer we got. Now we will be minus 9.8 divided by 2 is minus 4.9 t squared. When we apply integral formula, it happens. Then this over here is a constant, so you just add t, and then you have to add the constant of integration c. How do you find the c value? Substitute. It will be 19.6. Sorry, it will be 0. So substitute over here everywhere where t is there as 0. Over here, t is 0, 0, 0. What is h of 0? Initial height is 0. That is equal to this. All goes, and what is remaining? C. That is equal to 0. So a height, equation for height of the ball at any time t is negative 4.9 t squared plus 19.6 t. C is 0, so we don't write it. The first part is over. Now we need to find the maximum height and the amount of time the ball spends in the air. To find the maximum height, what we do is, you must always remember this. I'll explain why this is. the maximum height always occurs. Even in the coming problems, you will see the maximum height occurs when the velocity is zero. What does that mean? Now imagine like this. Okay, you start projecting something like this. It goes up and then it goes down, right? So when is the height maximum? When, see, the velocity is increasing, 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 and after a certain point it will start decreasing. All this position over here it's plus, here it's minus. You can see the slope plus and minus, right? When is it maximum? When the velocity is zero. See, whenever this particular point where it is null, in the sense it changes from plus to minus at zero, that is the maximum height. Always remember, h dash of t must be zero for the maximum height to occur. Okay, so why? Because it goes up, 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 and when it is zero over here, the velocity is zero, the slope is zero, that is h dash of zero, h dash of t is zero. Here, the maximum height occurs. I hope this is clear. So all you need to do is, what is the h dash formula? Over here we have, right? So we need to find the maximum height. Write this. This is the velocity equation we have. Now equate the h dash of t is equal to 0 and solve for t. Just take this to the other side, make it positive, and then divide 9.8 by 19. So it'll be 9.8 t equals 19.6. Sorry for the handwriting. Divided by 9.8 on both the sides, you will get t value. So it's basically 19.6 divided by 2, divided by 9.8, that is 2. You can check it out in the calculator. It'll be positive because this goes to the other side, both will be positive. So at time 2 seconds, you will have the maximum height. Okay, but is this the answer? We don't have maximum height, we have the time at which the maximum height occurs. So now what you have to do is substitute in the height equation t as 2 everywhere, and that is your maximum height. See, all you need to do is substitute over here 2. H of 2 will be minus 4.9, 2 square plus 19.62. This is the answer for the maximum height. H of 2 will be, if you put this in the calculator, let's just check, minus 4.9 multiplied by 2 square plus 19.6 into 2. So this is the answer, that is 19.6 meters. So this is the maximum height. So we have found the second thing as well, but we have not found the last part, how much time is spent in the air by the ball. So find time spent in air. How do you find it? So we need to understand. The ball lands at h of t is equal to 0, right? Always look, say if you're throwing something from the base, if it's going from the base over here, it goes like this, and when it falls down, it will touch over here. So there'll be 2 points. See, it starts from here and it falls down over here, right? So when it touches the ground, basically what is the height? Height is 0. So it starts from here, it goes up like this, and it falls down. So from this particular point, from 0, it is in the air. It is going, flying up, 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 and then it comes down. At h of t is equal to 0, this will be the second time, time 2. We need to find this particular time, because we will know from this time 1 to time 2, this is the a time. So how do we find that? It is very simple, because we just now saw we should just find the height 0. So this is the equation, right? Solve when this is equal to 0, you'll find the times. Okay, when it is launching and landing, we find both the times. So what we do over here is just make this equation h of t equals 0. Okay, so make it equal to 0, and then we will solve it. How do we solve this? It'll be minus 4.9 t square plus 19.6 t, right? Just, it's a quadratic equation. One side is equal to 0. So just put it in the calculator. Mod phi 3. Now what is before t square? It is minus 4.9. What is before t? 19.6. What is the last constant value? It's not there. Nothing is there, so it's 0. And one side must be equal to 0. The answer is t is equal to 4 and 0. See, it's at 4 and 0. That means the launching time, it starts at what? The initial velocity, it's there. 0 it starts and it reaches down at 4. Launching time is 0 and the landing time is 4. So how much time, how much seconds is the ball in the air? The amount of time the ball spends in the air is 4 seconds. Why? Because they launched at 0 until 4 seconds it reaches. So the graph in this, say it's 0 to 4. So this will be at 4, 0. This is the answer. To find the maximum height, this particular point at 2, it will be at maximum. We found out at time 2, we found the maximum height. So that is basically it. You can easily graph it as well if you want. But over here, the values are very important.